Here we have to evaluate the integral. That is, we have to evaluate. We have to integrate the function e to the x power positive e to the negative x power whole square times e to the x power negative e to the power negative x dx. Here, when I look at the function inside the integral, so the derivative of this part, that is e to the x power positive e to the negative x power, is e to the x power negative e to the negative x power. So the derivative of a part of the function is in the function itself, and it is multiplied by dx. In an integral, whenever we have the derivative of a part of the function is in the function itself, and also it is multiplied by dx, we can use the method of substitution. So that is, we have to substitute a new variable for the part for which we have derivative. Actually, we have derivative for this particular part. So I have to assign a new variable for this whole stuff e to the x power positive e to the negative x power. So let me assign a new variable t equals to e to the x power positive e to the negative x power. Okay, now I have substituted a new variable t for this stuff. So that means I'm going to change the complete integration to the new variable t. Actually, the original integration is in the variable x. So here they have done, we do integration with respect to x. Okay, when I change the complete integration to the new variable t, I have to integrate with respect to t. So that is, instead of dx, I must have dt over here. Okay, already I know that t equals to e to the x power positive e to the negative x power. If I want to get dt, to place it over here, so what should I do with this t? I have to find the derivative of this t. Actually, t is a function of x, so I have to find derivative on both sides with respect to x. Okay, let me do it. So the derivative of this t with respect to x is dt over dx. So the derivative of e to the x power is e to the x power, the same, and the derivative of e to the negative x power is the same, e to the negative x power. By chain rule, I have to do further derivative of this negative x power with respect to x. So the derivative of this negative x with respect to x is just negative 1. So now we have to answer by negative 1. Okay, so dt over dx equals to e to the x power. When I multiply this positive and negative, it will be negative 1 times e to the negative x power is e to the negative x power. Okay, now I'm going to multiply both sides of this equation by dx to get rid of the dx in denominator. So let me do it. Okay, I multiply both sides by dx. This dx will cancel out. I get dt equals to e to the x power negative e to the negative x power times dx. Okay, now let me take the original integral. So for this stuff, we have assumed t. So we can plug in t for this e to the x power plus e to the negative x power. But for this stuff, we have square, so we can take t square. And for this one, e to the x power negative e to the negative x power times dx equals to dt. So we can plug in dt for that one. Okay, so integrating this stuff is very simple because we just have to use the power rule of integration because we have a variable and we have an exponent. So we have to add 1 to the exponent, that is t cube, and divide by the same exponent by 3 positive c. Okay, t is a variable taken by x and it has to be replaced by the original stuff. So t equals to e to the x power positive e to the negative x power. So now we can plug in this stuff for t over here. So then I get e to the x power positive e to the negative x power whole cube over 3 positive c. So I got the integral of the given function. So this is the result of the integration, given integration.